Welcome to aminacademy.com. In vector calculus, let us discuss about gradient, divergence, and curl. Some introduction will do. What does gradient, divergence, and curl represent physically? The gradient is the direction of a greatest change in the field. That's where the point the greatest change happen in the field is called gradient. The divergence is the magnitude of the field as it emanates outward from a point. The curl is the magnitude and direction of the field as it circulates around a central point. Now we'll discuss further. The gradient is what you get when you multiply delta by a scalar function. That is, gradient of the function f is delta f equal dou by dou x, dou by dou y, comma dou by dou z of f, which is equal dou f by dou x, comma dou f by dou y, dou f by dou z. That is partial derivative. Note that the result of the gradient is a vector field. We can say that the gradient operation turns a scalar field into a vector field. That means the delta operates the scalar field into vector field. The divergence is what you get when you dot delta with a vector field. That is, divergence of field f is equal delta dot f vector, that is dou by dou x, comma dou by dou y, comma dou by dou z dot product f1, f2, f3, f1 comma f2 comma f3, which is equal dou f1 over dou x plus dou f2 over dou y plus dou f3 over dou z. These are also dot products. Note that result of divergence is a scalar function. When we can say that the divergence operation turns a vector field into a scalar field. That means from vector to scalar field it changes. That means divergence changes vector field to scalar field. The curl is what you get when you cross delta with a vector field. The curl of f vector is delta cross f vector, which is equal dou by dou x, comma dou by dou y, comma dou by dou z, cross product of f1 comma f2 comma f3. Note that the result of the curl is a vector field. We can say that the curl operation turns a vector field into another vector field. Now let us discuss further about some formulas of delta. If vector A and vector B are differentiable vector function and phi and psi are differentiable scalars functions of position of x comma y comma z, then we can write the formula. Look at here, delta of phi plus psi is, that is distributive. That means gradient of these things is equal to gradient of first one plus gradient of the second one. Like delta dot operation of A vector plus B, that is here also distributive, that is divergence of A plus B equal divergence of A plus divergence of B. Here delta cross A plus B is, here delta cross A plus delta cross B distributive, and which is delta cross A is curl of A plus B, which is equal curl of A plus curl of B. Delta dot phi of A vector is delta phi of dot vector A, that is here is A come out, plus phi of delta dot A. Fifth one, delta cross psi of A is delta psi of cross A plus psi of delta cross A vector. Here, like delta dot A cross B is B order changes, B cross delta dot cross vector A minus vector A dot delta cross vector B. Seventh one, delta cross A cross B is equal, here dot product, here cross product, here equal B vector dot delta into vector A, like B vector into delta dot A vector minus A dot delta vector B plus A vector dot A vector into delta dot vector B. Similarly, we can write delta of A dot B is like delta of delta phi is equal delta square phi, that is given dou square phi over dou x square like y and z, where delta square is here is called a Laplacian operator. The delta square is Laplacian operator. Next, delta cos delta of phi is 0. The curl of the gradient of phi is 0. Here delta dot delta cross A equals 0. Therefore, divergence of the curl of A vector is 0. Next one, delta cross A, all are cross product here, which is equal delta into delta vector A minus delta square A, where delta square is a Laplacian operator. Like this, these formulas are useful in further problem solving. We have done. Please subscribe our YouTube channel.